Bismillahirrahmanirrahim. Welcome to the third part of 19th lecture of Statistics and Probability Theory. We will continue with the topic normal distribution. Applications of the normal distribution. We will discuss some examples here. DGP University conducts the placement examination to all incoming freshmen. The examination scores of the 1000 examinees last semester were approximately normally distributed with mean score of 80 and a standard deviation of 5. What is the probability that the randomly chosen students got a score below 70, above 80, between 75 and 90? So basically you have to find out all these three probabilities, and here we have our random variable. Let's suppose it is x. So x, which is equal to the, what is normally distributed? Normally distributed, the examination scores are normally distributed. So our random variable is associated with the examination scores of the examinees, and which is the scores, examination scores, and these scores are, it means this random variable is normally distributed. This n is representing the normal with mean mu, which is 80, and standard deviation 5. So what they are asking us, find out the probability that randomly chosen student got a score below 70. So score below 70, as x is representing the score and it's below 70, it means it's less than equal to, less than or equal to, or less than, you can simply write it as less than, as it's continuous probability distribution, so it gives us the same meaning. So this is 70. So you have to find out this probability, x less than 70, for the first case. And the next one is above 82. So this will be probability x greater than 82 or greater than equal to 82. Both will give us the same meaning. And between 75 and 90. So in this case, you have to find probability between 75 less than or less than equal to x less than equal to 90. So you have to find all these three probabilities. As we have discussed in previous part, that for our convenience, we will convert this random variable x, which is converted into standard normal distribution with mean 0 and standard deviation 1. So the first case, as you know, mean is 80 and sigma is 5 as it is written here. So the z is x minus mu over sigma, as x is 70 minus 80 over sigma, which is 5. So this will be equal to minus 2. So the probability x less than 70 will be converted into probability z less than minus 2. So you have to find this probability. For our convenience, what we will do will be, we will sketch this graph. This is the normal curve and mean is 0. You will get minus 2 somewhere here, and you have to find probability z less than minus 2. So this would be the area z less than minus 2. And but the problem is that your table is giving the values from mean to some specific value. This is the half of the part of the table. The rest of the table is shown in previous part slide. You can uh, see from there. So this is the table, and you have to find the probability z less than minus 2, which is this area. But the problem this is, table is giving us the probability or area from mean to some specific value. That is, your table will give us value from mean to minus 2, but it will not give you value less than minus 2. So what will you do? As you know that you can find out the area between 0 and minus 2 from the table. So we will go to the table and find out the area between 0 and minus 2. As you know that normal distribution is symmetrical and identical, so you can find out the area corresponding to the random variables values 2 in case of the z is equal to minus 2. So 2.0, you will search in the column with 0.00, which is 0.4772. So this area is 0.4772. So what you will do, as you know that total area under the curve, normal curve, is 1, and this area is this area is 0.5. This one is split into two parts. This is 0.5 and this is 0.5. So whole this area is 0.5. If you subtract 0.4772 from 0.5, you will left with this area, which is our required area. So all this area is 0.5, and by subtracting 0.4772, you will get the required area. What we have done, probability z less than minus 2 will be equal to 0.5 minus probability 0 less than z less than 2, or you can write it in this way too: probability minus 2 less than z less than 0, which is 0.4772. So 0.5 minus 0.4772 will be equal to 0.0228, or you can say 2.28%. So this is the probability x less than 70 that the student selected at random will score less than 70. The next part is that the student selected will select above, will score above 80. So it will be 80 above 82. So it will be 82 minus 80 over 5, which will be 0.4. So this is z is equal to 0.4, and it will be probability x greater than 82 will be probability z greater than 0.4. So by constructing the graph, so this one is the area which is greater than 0.4. Again, the problem is in the table we can find the area between 0 and 0.4, but we will not have the area above than 0.4. So what we will do, we know that all this area is 0.5, and this 0.4 area, and the area between 0 and 0.4 is You can see from the table, which is 0.1554. It is area between 0 and 0.4. So where is 0.4? This is 0.4 and this is the area 0.1554. So by substituting it here, 0.5 minus this particular area point, if I draw it independently, it would be, I will change the color of the ink. So this would be the graph and this would be the mean 0 and this is the point 0.4 and all this area is 0.5 and this area between 0 and 0.4 is 0.1554. So by subtracting the 0.1554 from 0.5, you will left with this particular area, which is the required area. So it will be 0.5 minus 0.1554, which is 0.3446. Now you have to find between 75 and 90. By substituting the values, you can find out probability Z1 less than equal to Z and less than equal to Z2, and by drawing the graph you will see that here it is the mean 0 and you can locate 75 and 90, so it will be two values. This one be here something Z1, you can get it by substituting Z1 and X1. As X1 you can take X1 70 and you can find out Z2, which is X2 minus mu over sigma, and Z2 will come somewhere here, and this is the required area you have to find out. So I am leaving this question here up to you. So what will be the probability Z1 less than Z less than 2? This will be your practice question. So let's calculate it and find out what will be the probability.